Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 11 students and the topic of discussion is sequences and series. In this video we will be focusing on NCERT solutions for exercise number 2. In the first problem we need to find the 20th and nth term of a GP whose sequence is 5 by 2, 5 by 4, 5 by 8. The first term is 5 by 2, which we write it as A, and the common ratio will be second term divided by the first term, 5 by 4 divided by 5 by 2, which is half. Now we need to find the 20th term. So 20th term is given by A20 equal to AR n minus 1. N is 20 here. We just substitute the values of A and R from here and get A20 as 5 divided by 2 power 20. Similarly, An will be AR n minus 1. We again substitute value of A as 5 by 2 and R as half and get An as 5 divided by 2 power n. In the second problem, we need to find the 12th term of a GP whose 8th term is 192 and the common ratio is 2. So R is 2 given, 8th term is 192. We substitute A8 as AR 8 minus 1, which is AR 7, which is equal to 192 given. A is already to be determined and R is given as 2, so we can easily compute A as 3 by 2 by substituting in this equation. Now we can get the 12th term. A and R are known, so we can find the 12th term. 12th term is given by AR power 11. We substitute A as 3 by 2 and R as 2 and get A12 as 3072. In the third problem, the 5th, 8th and 11th term of a GP are P, Q and S respectively. We need to show that Q square equal to PS. So the 5th term can be written as AR 5 minus 1, which is AR power 4, which is given as P. Similarly, AR power 7, which is the 8th term, is given as Q, and the 11th term is given as AR power 10. This is equal to S. So now what we do, we divide 2 by 1. So it will be AR power 7 divided by AR power 4, which is Q by P, 2 divided by 1. So R cube will be Q by P. Similarly, divide 3 by 2. So we again will get R cube equal to S by Q. So from 4 and 5, R cube is there. So we can write Q by P is equal to S by Q. Solving gives Q square equal to PS. That's what we wanted. In this problem, the 4th term of GP is square of the second term. We need to find, and the first term is minus 3. We need to find the 7th term. So A is given as minus 3 and second term is given by A2 equal to AR n minus 1, AR1, which is minus 3R. Similarly, A4, the 4th term is AR cube, which is minus 3R cube. Now the 4th term is square of the second term. So 4th term is square of the first term. This is what we write here. Solving gives R as minus 3. So A is known as minus 3, R is known as minus 3. We can get the 7th term as AR 7 minus 1, AR 6. Put minus 3 power 6, which is minus 3 power 7, which is minus 2187. In this problem, we need to find which term of the sequence is 128. The first problem, 8th problem. So A is 2, R will be 2 root 2 by 2, which is second term divided by first term, which is root 2. So we need to find nth term, which is that n value which gives the sequence as 128. So we write AR n minus 1 equal to 128. Put A as 2, R as root 2. So we get this as 2 into 2 n minus 1 by 2 equal to 2 power 7. 128 can be written as 2 power 7. So this will become n minus 1 by 2 plus 1, because power 1 from this 2 will be added here. So we can write n minus 1 divided by 2 plus 1 equal to 7 and get n as 13. So 13th term of sequence is 128. For what value of x the number minus 2 by 7 x, 2 by 7 are in GP? So we can write the common ratio as the second term divided by the first term. So x by minus 2 by 7, which is minus 7x by 2. Similarly, common ratio is also minus 7 by 2 by x. So we equate these two and get x square as 1, x equal to plus minus 1. So x could be 1 as well as minus 1. Find the sum of 20 terms in the GP 0.1, 0.015, 0.0015 and so on. So A is 0.15, R will be, or common ratio will be second term divided by first term, which is 0.1. So we need to add the 20th terms. So formula is Sn equal to A into 1 minus R power n divided by 1 minus R. A is known, R is known, we substitute and get S20 as 1 by 6 into 1 minus 0.1 power 20. In this problem, we need to evaluate sigma 2 plus 3k, where k is from 1 to 11. This means summation term. So this will be 2 plus 3 power 1, 2 plus 3 power 2 and so on till k is 11. So how do we segregate the constant terms and the power terms separately? So this will be 2 plus 2 11 times because k is 11. Similarly, power terms will be 3 power 1 plus 3 power 2 and so on till 3 power 11. This will be 2 into 11, which is 22, and this we need to compute. So how do we compute this? We will check whether this forms a GP. So the second term divided by first term is 3. Similarly, third term divided by second term is 3. So common ratio is same. So it is a GP and we can use the standard formula now. We can use this formula A Rn minus 1 by R minus 1, where A equal to 3, R equal to 3 and N is 11. We just substitute in this formula and get the summation as 3 into 3 power 11 minus 1 by 2. And in the final equation also now we can add 22 plus this as 22 plus 3 into 3 11 minus 1 divided by 2. So this is the final answer. In this problem, we need to find the sum of n terms of the sequence 8, 88, 888 and so on. Now let us see if it is a GP, we can easily find the sum using the formula. So let us see if it is a GP. 88 by 8 is 11. 888 by 88 is not 11. So this is not a GP. So how do we proceed? We write this as 8 into 1 and this as 8 into 11 plus 8 into 111 and so on. We need to find sum of this. Now take 8 as common and we can write this as 8 into 1 plus 11 to 111 plus so on. Now we multiply by 8 by 9. So this will become divided by 9 into 9. So this will become 8 by 9 into 9 into this. So this inside bracket will be 9 plus 99 plus 999 and so on. And this 999 can be written as 10 minus 1, 100 minus 1, 1000 minus 1 and so on. Minus 1 and power terms can be separated. This can be written as 10, 10 square, 1000 and the power terms are added separately and the constant terms are added separately. Now we see that 10, 10 square, 10,000, this is a GPY. 10 square by 10, second term divided by first term is equal to third term divided by second term. So common ratio is 10. So we can find the sum now. We can find the sum of those power terms 10 into 10 n minus 1 by 10 minus 1. Now we substitute back into the original equation of this 8 by 9 into sum minus n. So 8 by 9 into this can be simplified to 80 by 81 10 power n minus 1 minus 8 by n. In this problem we need to insert two numbers between 3 and 81 so that resulting sequence is a GP. So if we want to insert n numbers between two numbers, we use the common ratio can be determined by the formula b by a, 1 by n plus 1. A and b are the two numbers in which we are inserting n numbers. So here a is 3, b equal to 81 and we need 2, so n is 2. So we use the formula this to get r equal to 81 by 3, 1 by 2 plus 1, r is 3. So now we have a equal to 3, r is 3, b is 81, first and last number. This is the common ratio. The first number in between number will be ar n minus 1 formula, ar power 1 which is 3 into 3 9. Second number will be ar 2, ar power 2 which is 3 into 3 square which is 27. So the two numbers between 3 and 81 will be 9 and 27. In this problem, the number of bacteria in a certain culture doubles every year. If there are 30 bacteria present in the beginning, how many bacteria will be present at the end of second hour, fourth hour and nth hour? Since it is doubling every hour, it forms a GP with R equal to 2 and A is given as 30. So in the second hour, it will be A equal to AR power 2, which is 120. We can put A and R as 30 and 2 in this equation. Similarly, fourth hour, it can be given as 480, A equal to AR power 4. And this is end of fourth hour or the beginning of fifth hour. That is why it is 4, not 3. The number of bacteria at the end of nth hour will be An plus 1 equal to Arn by 30 into 2 power n. So kindly note that the end of second hour is beginning of third hour. So we are putting AR square and not AR power 1. This is very important. What will rupees 500 amounts to 10 years after a deposit in bank which pays annual interest of 10% compounded annually? So amount is principal into 1 plus 1 by R. So this is 10%. Principal is 500. This is the amount. So this at the end of first year it will be 500 into 1.1. At the second year, this will be the principal and it will be 500 into 1.1 into 1.1. So similarly at the end of 10 years it will be 500 into 1.1 power 10. In this problem, arithmetic mean and geometric mean of the roots of a quadratic equation are 8 and 5. Then we need to find the quadratic equation. Arithmetic mean is given by a plus b by 2. A and b are the roots of the quadratic equation. So a plus b can be given as 16. Geometric mean is given as 5. So geometric mean is given by the formula square root ab equal to 5. ab equal to 25. Sum of the root is given. Product of the root is given. Quadratic equation can be determined as x square minus x into sum of the roots plus product of the roots equal to 0. Just substitute here and we get the final equation as this. Friends, with this we conclude this video. I hope you like my video. Please like and subscribe my channel so that in future videos can be released to you quickly. Thank you very much, friends.